Hello and welcome to SudoKanard. It's been a while since I did walkthrough videos about puzzles in Sudoku Grand Prix. I haven't been consistent this season, but this is how things go, and I apologize for this. But one viewer asked me to cover this very puzzle from the latest Sudoku Grand Prix, so I thought I would oblige. This is Greater Than Killer Sudoku by Czech author Pavel Kadlečík. I hope I didn't butcher your name. It was worth 81 points. It was not the highest pointer in the set, but it was among the highest pointers. And this is a variant of Killer Sudoku, which is quite well known for people who know the website Daily Killer Sudoku. But I think this is the first time it has appeared on Sudoku Grand Prix. So the usual rules of Killer Sudoku apply, which means that in every cage, like this cage here, all digits must be different. But instead of giving the sum of all digits in the cage, which is the usual Killer Sudoku rule, here we only have an inequality signs between the totals. So the sum of those three digits is bigger than this digit, which is bigger than this one, which is bigger than this one. And sometimes an equal sign is given, but I replaced the equal signs by those gray circles because that's the most convenient notation I could find on PenPal for this. I couldn't solve the puzzle during the contest because, well, I still need to work on my mental preparation. But soon after the contest was finished, I tried it again and found the break-in. And I will show you the break-in right now. The way to start such a puzzle is to find long chains of inequalities. And the long chain starts here. Here we have a cage whose total is smaller than the total here, which is smaller than the total here, which is the same as that, which is smaller than that, smaller than that, smaller than that, smaller than this. And the interesting part here is that this can't be too low. With 4 digits, the sum is at least 10, and here it can't be too big. With 2 digits, it can't be bigger than 17. So let's see what the options are. So the minimum here is 10. Here the minimum is 11. Here the minimum is 12, same here. Here the minimum is 13. Here it's 14. Here 15. Here it's the same, 15. Here the minimum is 16. And as I mentioned earlier, the maximum is 17. So we only have 2 options for the sum of the digits in those cages. And we need to disambiguate that. So the disambiguation will happen in this region. So the sum here is either 12 or 13. Here it's either 11 or 12. And let's imagine we are in the lowest scenario. By this I mean that those cages have a sum of 12. This cage has a sum of 11. So those 8 digits in total sum to 35. And you need to know when you solve Killer Sudoku that the sum of all digits from 1 to 9 is 45. This is the best kept secret in Sudoku. And it will mean that this set contains digit 10, which is not possible. So those cages can't have a sum of 12. They must have a sum of 13, which is the maximum possible. And then this has to be 14, this has to be 15, this has to be 16, this also has to be 16, and this has to be 17. This can still be 11 or 12, this can still be 10 or 11, and this will have to be disambiguated at some point later. All right, so that's a very nice start, I must say. Now let's do some Sudoku. That's some killer Sudoku, I should say. 16 with 2 digits has to be 7 and 9. 17 with 2 digits has to be 8 and 9. This can only be 8. This is 9. And this is at least 18. This is also at least 18. This is at least 19. But I don't think I can do anything with that at this point. 16 with 5 digits can only be 1, 2, 3, 4, 6. This is something you need to know if you do consistent Kira Sudoku. 14 next to 15 is also very constrained. 15 is either 6, 9 or 7, 8. 14 is either 5, 9 or 6, 8. But what you need to appreciate is that if you try to put 6 and 8 in those cells, then no option remains for 15. So this has to be 5 and 9. And this can't be 6 and 9, it has to be 7 and 8. Now this 13 cage doesn't use 6 and is not 6 and 7, it's not 8 and 5, it has to be 4 and 9, which means that this is 5, this is 9. This still has 2 options. Now let's have a look at this. 10 is with 1, 2, 3, 4. 11 is with 1, 2, 3, 5. Those are the only options for this total with 4 digits. And you can see that both options require the 1, the 2, and the 4. And sorry, the 1, the 2, and the 3. So 1, 2, and 3 can be eliminated from those, so that this is a 4-6 pair. I can eliminate 4 and 6 from those cells. This is 9, this is 4. And I can eliminate the option 1, 2, 3, 4. So this is actually a 1, 2, 3, 5 quadruple, which means that the sum is 11. And because of the inequality sign, the sum here is 12. Now this 12 cage does not use the 4, and the only option remaining is 1, 2, 3, and 6. So the 3 remaining digits here are 5, 7, and 8. Those two must sum to 13, so 7 is excluded, and 7 goes there. 7 plus this is less than 12, so this must be a digit from 1, 2, 3, 4. Well, I will use heavy pencil marking. I usually don't do that, but no, I'm doing this time. Now, here we must have 7, 8, 9, so this is 8, this is 7 and 9. And I'm not sure what I'm about to say is useful, but I will say it anyway, because that's, I say it anyway, that's in the lyrics of the song Take On Me. All right, so what was I saying? This is a 1, 2, 3, 5, 6 quintuple, which means that we need those 5 digits to complete those 5 cells. So we know that the 5 digits will be in those 5 cells. And inside this quintuple, the 6 is in here, so it will never be here. Oh, sorry, it will never be here. If I try to put a 6 in there, I don't have the 6 here, so I have 1, 2, 3 here. And with 1, 2, and 3 here, I must put the 5 in those 2 cells. That doesn't work. And similarly, the 5 must be in here. If I try to put the 5 in here, then I put 1, 2, 3 here. I put 2 digits from 1, 2, 3, and I don't have enough digits available here. I don't think that's correct. Now, what I should say is that, so here I have the 6, and I have 2 digits from 1, 2, 3. So only 1 digit from 1, 2, 3 is available here, and the second digit must be the 5. All right. So the 6 is in here, the 5 is in there, and we get a 1, 2, 3 triple here. I'm not sure this will be useful for what follows. So anyway, another way of seeing things is that 4, 7, 8, 9 have to appear in those cells because they don't appear in those cells. So Those are from 5, 7, 8, 9. This is smaller than that, so this can't be 9, this can't be 4. And this must be smaller than that, so it can't be 9. This is from 8 and 9. And this can't be 8. And by the way, this 8 tells us that this is 5, this is 8, and this 8 tells us that this is 9, this is 7, this is 9. This is at least 10. And here we have 1, 2, and 3, which is interesting. Here we have 5 and 6. And you see that having 5 and 6 here does the elimination that I did earlier, but in a much easier fashion. So now this must be the same as that, which is 12 or 13, but the only way of achieving this is to have a 4 there and a 6 there. That's 5, that's 7, that's 8. So the sum here is either 9, 10, or 11. Oh, and I'm seeing very nice logic here. I don't remember if I saw this when I solved it the previous time. So the logic here is that those cages have the same sum. So the total sum of those digits is a multiple of 3. It's 3 times the total of each. And we know that the sum of all 9 digits is 45, which is also a multiple of 3. So the difference between them must be a multiple of 3. So this cage total is a multiple of 3, and so is this one. So the sum must be 9. 12, 10, and 11 are not multiples of 3. That's a knowledge bomb from SudoKanard. This 5 is not here. 5 goes there. And the sum must be a multiple of 3. So it could be 5 plus 2. Sorry, it could be 5 plus 1. Actually, it could not. If I try to put 5 and 9 into those cells, so then the sum, oh, sorry, the sum must be 9, so this is 4 and 5. Sometimes I forget what I'm doing. So now the 6 inside this box must be in here. The sum is 9, so this is 3 and 6. There's no 3 in here. The 3 inside this cage is there. That's not 3 anymore. That's not 3 anymore. And this 1, 2 pair makes this a 3 and that a 5. All right, so now I'm seeing that on this row, 8 must be inside this cage. The sum is 9, so that's 8 and 1. That's 2, that's 1, that's 4. Sum of 11, this is consistent with the sum of 12 here. And I have the feeling that this inequality sign was not needed. This is 7. And now, what is the sum? Here we have 9, so the remaining total here is 36, so each sum has a total of 12. This is 5. 12 here with 2 digits, it's not 8, 4, it's not 5, 7, it must be 3 and 9, so that's 9, that's 3, 7, 9, 8, 7. Here I need 1, 2, and 6. Here, this is not 1, this is from 2 and 6. Those are from 2, 4, 6. Here I have a 1, 2, 3, 6 quadruple. 3 is in here, so that's not a 3. And actually the 3 on, and this is also not a 3, that's the 3. Here I need 5, 8, and 9. This is not 9. So this must be less than 8. It can't be 2 and 6, so that has to be the 1. 1 and 6 would work with an 8. 1 and 2 would not work because that's the 2. So that's the 6, that's the 2, that's 6, no, sorry, that's a 2, that's a 3, that's a 2, and now the sum is 7, so this has to be 8, and this has to be 9 for the equality sign to hold. Where do we go from here? Let's... Oh, that's really beautiful. I don't remember seeing this when I sold it. So here the sum is 17. So here the sum has a minimum of 18. So minimum of 18, minimum of 19. So minimum of 37 for this, which means that those 3 cells have a maximum of 8. But with a 5, it means that those 2 cells have a maximum of 3. And 3 is also the minimum value for the sum of 2 cells. So that's the 1, that's a 2. And we can see that the sum here is 18. And the sum here is also 18. And the sum here is 19. Here the digits are from 3, 4, and 6. And 3 is one of them. 1, 3, 4 would make a sum of 8. 1, 3, 6 would make a sum of 10, but this is a single digit, so 1, 3, 6 is not possible. So this is 1, 3, 4. It's a sum of 8. Now the sum of 8 can only be 2 and 6. That's a 9. Here we have 5 and 7, so 7 is here, 5 is there. For a sum of 19, this must be 3. Here I need 4, 6, 8. That's not 8. That's not 8, so that's the 8. This 3 here disambiguates that. Those here are 1 and 2, so this is 1, this is 2. This column needs a 7. Those must sum to 11 from 4, 5, 6, so they must be 5 and 6. This is 4, this is 6. This disambiguates the digits up there. Down there, I need here 1 and 3. So this is 3, this is 1. This is 7, this is 4. And this does the trick. And I don't think I used the fact that those two cages must have the same total. I think it just came about. So that's 12, that's 12. This is correct. So there are probably a few clues that were not needed, but perhaps they offered an alternate way of finishing the solve of the puzzle. So that was a really, really well-made puzzle, I must say. I just wish I had seen the breaking during the contest, but then I've had a horrible season as a solver, so this is only consistent. Thanks for watching this video, and see you soon on SudoKanard.